I'll be joined by two of my colleagues, Jacob O'Shea and Ken Bigelow, who are the HPC systems administrators, also at ARC UBC. Next slide, Ken. And do let me know if my voice is not coming through clearly. I hope I'm speaking loud enough for all of you. Just a quick intro on what UBC ARC is. So UBC ARC is a unit under the Vice President Research and Innovation at UBC. And we're a free service or unit, as it were, that we provide support for advanced research computing for the entire campus, both campuses actually, at UBC Vancouver and UBC Okanagan in Kelowna. So we're discipline agnostic. We do have some domain-specific experts, but we try to provide support for any type of research across campus, whether it's traditional disciplines like chemistry, physics, bioinformatics, or even things like digital humanities, et cetera, et cetera. So if somebody has research or a problem that requires HPC, cloud, big data, that type of support, we're kind of the one-stop shop for that for the campus, and we try to provide resources or consultations to use systems, whether they're on-prem systems, whether they're commercial cloud, whether they're nationally available systems, et cetera, et cetera. So we try to find the best solution for the researcher and go from there. Currently, right now, ARC has about 30 members of staff in various disciplines and 4 different teams providing various types of advanced research computing support to the campus. Next slide, Ken. So one of the things that we found while providing the support and doing consultations over several years was a lot of folks started using commercial cloud. And most people would say, hey, I sign up for an AWS account or an Azure account with a credit card and go from there. And they'll learn how it works. They'll get a postdoc or a graduate student to learn how the cloud works, essentially become their system administrator. But of course, what happens after a few years is that person graduates or leaves, and then you start at ground, basically at zero again. So the thing about cloud is, why are people going to that? Isn't our on-prem resourcing sufficient? And I think that's the key crux of the matter is the on-prem resources that we have are definitely oversubscribed. So whether it's the HPC systems we run at UBC, so we currently have a 16,000 core HPC, but there are also national HPC systems in Canada. So Canada has a national alliance of research computing where resources are provided federally to researchers at different universities as well. And there are about 4 major systems there ranging from 30,000 to 60,000 cores each. So there's quite a decent amount of compute, but when you spread it across the entire country and all the researchers at the various universities here, it's definitely oversubscribed, and especially GPU resources over the past few years have been significantly under stress. CPU and storage maybe not as bad. So a lot of researchers are saying, yeah, I submit a job to a traditional HPC queue. Might take a week to get through the queue if I want to run a big job. I have a deadline to submit a paper to a conference or a journal. What do I do? So if you have funding, you can definitely go to the commercial cloud and say, hey, I'm going to set up my HPC in the commercial cloud. There are more resources available there. I don't have to wait. There's no queue wait time, et cetera, et cetera. So the scale, large scale deployments are definitely well suited for commercial cloud. Some of the researchers obtain direct grants and credit from any of the major cloud vendors for supporting their research as well. So there's been an organic growth in that area. So when we saw that, we thought, what can we do to maybe aid in the adoption of these technologies or maybe make things a little bit easier for our researchers to use cloud, maybe both on-prem and commercial, but maybe focusing a little bit more on the commercial, because on-prem cloud is also not as scalable, at least in our case, as what the commercial cloud provides. Next slide, Ken. So one of the issues that we noticed, straight off the bat, because a lot of our initial federal cloud that we have here is based on OpenStack. So the OpenStack platform, I don't know if many of you have used that. It's not the easiest thing in the world to get to grips with, but that also applies to things like Azure or AWS or GCP. When you're given an account to use that, if you're not a sysadmin, you're generally in a bit of trouble because you're like, how do I set up networking? How do I set up a VM? How do I do interconnections between different VMs in the cloud and so forth? So large research groups that have a lot of funding and have dedicated IT support, they can figure this out and have some dedicated support to keep these research projects going in the cloud. But a lot of groups don't have this dedicated support. You might have, as I said earlier, graduate student, a postdoc working on this. They graduate after a few years. Nobody knows what the passwords are to the infrastructure. Nobody knows how to get the data off there, et cetera, et cetera. So while the cloud does offer a lot of opportunities for a large amount of compute and the ability to reduce these queue wait times that you have on traditional HPC, there's a startup cost. So my manager likes to say activation energy, and I like that term. Is activation energy is quite high, and that activation energy takes away from the actual research. I mean, we expect the researchers want to focus on their work, run their jobs, or do their computations and things like that, not spend their time doing IT. So what could we do to assist that? That was kind of where we started from. How do we make access to the cloud easier? One way, of course, is to do training and other things like that. But is there some other way just to make it almost plug and play for researchers? Next slide, Ken. So for example, when you log into AWS, you see something like this, all these services. If you notice in this slide, it says 1 to 15 out of 239 different services. So when you have somebody, even a technically proficient person looking at this, you're like, what do I do with this? I need to be an IT person, but I also need to get a certification in the cloud, or AWS in this case. What do each of these services mean? So this is something to most people, especially somebody just doing research and is not an IT person. How do I make use of this? So the 239 services, they might be more now because they keep adding new services every week, it seems, at this point. So the complexities we found was far too high. We can't just subscribe them to an AWS or an Azure account and say, okay, here you go. Here's your X number of dollars in the cloud. Go ahead and start using it for your research. Next slide, Ken. So what we decided on was we looked at what are the core services that most people are using in the cloud. They're platforms like Jupyter, SageMaker, et cetera, that we know people are using, but the vast majority, what are people using? What do they need? So the core services, and this is from a HPC standpoint, but also could just be from any cloud, is we found with CPU and GPU compute, block and object storage, the traditional HPC where you submit jobs to a queue, on a certain number of CPU or GPU nodes, and finally cost management, because one of the challenges of using commercial cloud in any capacity is how do you manage your costs? How do you know how much you've used so that you don't overbill? That's another art unto itself. Next slide, Ken. So what we did is around 2019, and there's a slide with our timeline that shows some of that, I think the next one, we started looking at a platform called Ronin. So Ronin is a front end essentially to AWS. So what we like calling it is self-service with guardrails. So we integrated it with our university's IAM and single sign-on. You can add network security, so you can make it accessible only via VPN or some IPs that you permit to access. And it gives you a front end that provides access to those core services I talked about earlier, which are HPC compute, CPU compute, GPU compute, storage, backups, etc. So it provides that front end, that single sign-on with your university IAM system that a researcher can just log in, they see how much money they have, the cost management, and they can spin up these services with extremely low level of technical experience. So it doesn't provide everything that AWS provides, but I think it handles the 80-20 or the 90-10 use case where most people are looking for those core services and they go from there. And all the orchestration of the resources is handled automatically with secure defaults. And each time you orchestrate the resources, it also shows you how much it would cost from your allocation in the cloud. And Ken will show later a more detailed demo of that to maybe make it a little bit clearer because it's just text. But essentially, it ties in those 4 core services I mentioned earlier in a very easy to use platform. And we found that we had to do something like this because it wasn't feasible to train everybody on AWS and have them work with that complex UI or even the command line, which is even more complex. So we went with this solution as a POC. Next slide, Ken. So we started looking at it around 2019. That's when we started discussing, hey, where do we go with commercial cloud? And we had some funding from our VPRI to start several POCs and planning out a pilot with the eventual goal of having a service. So around 2019, we started talking to both AWS and Ronin, looking for a solution to this problem. And in 2020, we actually had the POC stood up. So it didn't take too long to stand up the POC. There's a little bit additional time to integrate it to our SSO and IAM, but not very long. So I should say that period between 2020 and 2021 is when we started reaching out to researchers and have them run on the system as a beta. The pilot offering, once the beta was concluded, was offered in 2021 to UBC researchers. And once we had more people running, so we essentially had people running continuously from 2020 up till now. But in 2022, we decided to offer it as a complete service and say, okay, it's a service that Arc provides. We fully support it, and we invite researchers to come into it. But we've generally had people running for it on it in a beta phase, and then a pilot phase, and then a final service phase since 2020. So we've had almost 3 years of experience with it now, and maybe about 40 different research projects from various disciplines running on it. And I think I'll pass it on to Jacob next, who's going to show us how we onboard researchers and how we do that. And finally to Ken, who will show us more on the technical side in the demo. So to you, Jacob.
Thank you. So a bit about how we get researchers from the point of they're just learning about cloud to actually running on Ronin. We offer on our website for Arc a request form to set up an account on Ronin, and what we'll do is we'll direct anyone who's contacting us or is interested in cloud into signing up on that application form. That form will then be sent to us. We'll do a consult, and then we'll get ready to onboard them into the system and give them a bit of training on here's how to use Ronin, here's all the fundamentals that you'll need to work with. So I'll break each of these down a little bit and go into detail. Can you get to the next slide, Ken? So as I was saying, we have an application form on our website. We direct anyone who's interested in cloud into using it. The researcher will get onto the website and go to the application form. We'll collect a number of different pieces of information about what their research project is that they'd like to use on a cloud service. And once they fill out the form, everything is kind of bundled together into a support ticket. And that's sent along to our support staff at Arc, and they will help us set up a consultation with the researcher. And in that consultation, in addition to kind of going over the details of what they've requested as far as what kind of cloud resources they'll need, what they plan to run on it, if they need any additional special help with getting things set up, we'll look at that and kind of work out a budget for the allocation that we'll set up on Ronin and go into any specific details as far as here's things that you can do on Ronin. Here's things like if you're using controlled data, you need to be aware of where this data is going to live on the cloud, what kind of data sovereignty regulations are, and all of the various kind of either security or even programmatic bits about how to run in the cloud. And Ken, next slide. So once we've had that initial consultation, we'll go through the process internally at Arc with onboarding the researchers. The researcher will provide us a list of basically anyone in their research grant that they are authorizing to utilize the funds that are set up in Ronin. We then go through and onboard each of those users into Ronin. We use a campus-wide login that is a shared system across campus that's used for all sorts of other services, and they will use that same account to log into Ronin to manage any of their virtual machines or storage that they set up using Ronin. We then take all those users, they're attached to a single project, and we set up the project with the agreed upon budget for the researcher. Once we finish all the onboarding, we'll send out a welcome email to the researcher and all of their colleagues and let them know that their Ronin account is set up and is available for use, and we will offer a short training session for anyone in the group who's interested on here's the basics of Ronin, here's how to start up a VM. It's usually a pretty kind of short session. Once we get into the actual UI, I can probably walk through, myself or Ken will be walking through pretty much all the fundamentals of how to set up resources in Ronin today during our presentation. And then we offer, of course, any further questions or any thing that comes up during the course of the allocation. We have a support channel set up through our ticketing system where we'll either contact one of our support staff for an easy question, or it'll get passed up to one of the system administrators or cloud specialists to help them further. Next slide, Ken. So now that we have, from the researcher's point of view, as a researcher, I've just been granted an allocation on Ronin. I log in, I can see my project dashboard of here's what's available, and here's how Ronin displays everything in a nice single pane. We can see on the left side, we have a kind of a brief description of the project, how many days are left in the timeline, which region, as far as AWS is concerned, as to where the actual VMs will be sitting. This is important in the cases where we need to show data sovereignty, where a certain amount of data can't be exported outside of the borders of Canada. And then across the top, we have probably one of our researchers' favorite parts of this is a budget forecast of here is what we have as far as what I've spent so far in my project, what I'm forecasted to spend over the remaining timeline that we have set up, as well as the total budget and how much is remaining. And all this is calculated by what we have running and what we have set up as storage. So right below that, we can see our list of running machines and how a nice, easy to see dollar amount per hour of how much those machines are costing our project. And as we can see in this project, we don't have anything running, so the cost is 0, but we do have already 5 machines pre-allocated and 1 cluster set up. And if you notice at the top, we have a forecast that is slightly higher than what we've already spent on the project. And that's because at the bottom here, we also have our storage that's listed. And this is basically any storage that is set up and attached to the system that is remaining persistent. That also has a cost attached to it, much like a running VM does, but because the storage is never deallocated until it's deleted, that cost accrues constantly, even if the machine is offline. And that goes into the forecast, and we can see that because we have about 1.6 terabytes of SSD storage, we're going to be burning about $141 per month. And that adds up all together to the budget and helps keep the forecast tied to that timeline that we have left. So on to the next slide. So this is I'm going to lead this into the demonstration that Ken will be doing, but in this case, we've started up a one of the other features that Ronin can do is build an auto-scaling cluster. So much like an HPC system that you have on site, you can set up Ronin to build and manage a scheduled system just for your project, where users can log in, run their job submission scripts, and based on the workload, Ronin will start and stop compute nodes that are attached to kind of the cluster space. And as the queue finishes out, it will start draining those down to whatever minimum that you have set. And Ken will go further into it here during his presentation, and I will hand it off to him to give us a nice live demo for everything.
Right on. Thanks, Jacob. Can everybody hear me okay? Great. Okay. So I'm just going to stop the share here for a second and just clean up this desktop a bit. And then I'm going to jump into the actual sort of a live demo. Because I have a little bit of extra time, it looks like, I can actually show you another thing too. So I can spin up a single VM, a Windows VM, and show you how easy that is too. So yeah, just give me 2 seconds here. And I'll give extra time. It looks like we might have lots of questions because there's lots of people here. So maybe I'll give a few extra minutes too for questions. Okay, can everybody see the dashboard here? Yes?
Yep.
Okay, good. So it sort of looks just like what Jacob was saying. So I'm going to sort of explain, as I was I'm a brand new researcher. I've just been onboarded. Maybe I've got the training, maybe I haven't. And maybe my topic was, I'm a researcher that wants to work with the software Fire Dynamic Simulator, FDS, and SmokeView to design some simulations around possible scenarios like forest fires, wind speeds, dryness of the forest, all that kind of good stuff. And so I wanted to, maybe I had experience with traditional HPCs, so I understood what a scheduler was, I understood what software stacks were, but maybe I just have never used a cloud before. So that's kind of maybe where we would start at. So yeah, this is sort of the workshop I took. There's a nice little GitHub page here. I sort of learned about it through ARC, and I understand what's going on. So here I am at the dashboard. So first thing I'll do is, because I'll start with the Autoscaling Cluster, so they do take a little bit of time to spin up. Fortunately, because it is a demo, I did put one up, and it's my example one, and it is up and running and ready to go. So I'm going to go for a new Autoscale cluster. And so when you get this is the first screen you get. And so I like Ubuntu, so I'm going to go with that. We go with anything that you like there. I'm going to go with Slurm just because it's the most common. Those two are available, but that's what I like. And then I'm going to enter my name here. I'm going to call this today's demo. Maybe I'll keep it all lowercase just to keep things continuity. Right, and then it's available, good. And so then you have over here your head node and your compute nodes. So I always like to keep, generally if I was an HPC guy, I would know that, your head node is going to be, it doesn't need to be that powerful unless you're going to be building software, and then you might want to change that. So for now, for this process, we'll just leave it. But if I was going to install software stacks with SPAC, I would probably put it to a T4 large with 4 cores and lots of memory, because it just does speed time up, and the difference in cost is not much, and I'll show you that as we go along. And the compute nodes, so we're going to change those because maybe I want a little bit more. Okay, so I'm going to go with, say my my simulation needed lots of processes but not much memory. So I'm going to scroll down here and have a look. And this looks like it's probably best bang for your buck, maybe the C4 large. So we'll grab those because we're going to be grabbing lots of them. Okay, and then your app storage and your shared storage. So those are the storage that are going to be shared across your head node and all your compute nodes. So depending on what you're going to want for your results or your apps, you would change this. Usually I'll leave that just as it is, but you can put 100 gigs, whatever you want. And then the SSH key is the next part. So if you spun up something before, you'll have one. If not, you'll get a new one. And so in this case, I'm just going to make a new one for fun. Call this a demo. Array key. Great, and then it copies it for me on my desktop to PEM, and then if you were to use like a third-party SSH client like Putty, you would have to set that up with the right permissions on the back end, or if you're using a Windows substitute, Windows for Linux in your Windows side. you would have to just set up the permissions to really strong, and then you could just SSH using that key and the username of Ubuntu. So close that. We've got it. We've selected it, I think. Yep. It shows here. Yep. Okay. So let's just make sure. Okay, it's in the downloads file. Okay, good. So we have that. Where did it go? Did I lose it? No. Oh, I'm so sorry, guys. We'll go quickly here. Oh no, it's still here. Sorry. Okay, so then we're going to go to the nodes. So there's 10 machines max and min. That's fine. So we'll just go with that, and that just shows you how much you want. The min is obviously 1, and the max of the compute nodes is 10. And so then you have the spot and the market pricing. And with the on-demand and spot, I found that it's better to go with the on-demand, especially with larger jobs and GPU jobs, because you have a better chance of getting it. If you enable spot, what can happen is you can be waiting a long time, but in the meantime, it looks like the system's spinning up all the nodes you've asked for, and sometimes you could be paying for the nodes when you're not getting them quite yet. So when you go with the on-demand, it just works better. And you can, yeah, it just works. And then leave that by default, and then it sort of shows you on the defaults here what it would be if you were using the these power setting at the end. I'll show you there's some power settings you can do, and it shows if you were going to use this on the weekends, 9 to 5 or all the time. And so once you've got all that in, you'll see here, launch my cluster, and it'll be created. Now this takes a few seconds because it's got to set up the head nodes, and then it's got to set up the compute nodes. And that takes about 5 minutes. So while that's setting up, I'll show you how easy it is to set up a standalone Windows VM and connect to it and show it to you, because we still have lots of time. It's just 10:30 now, so that's with you guys. So machine summary.
There also are a few questions people have been kind of chiming in with, but you can choose when you want to tackle those.
Yeah, I think we'll get to the end just to go with and we'll leave extra time for that, if that's all right with everybody.
Okay.
Oh, sorry, I go back there. I won't be long, really. We're close. This is really quick. So let's go to the new a new standalone machine here. So the nice thing about the standalones and the autoscale clusters is if you were setting this up for a big team, you can actually build up your machines, and then you can actually save them and package them up pre-configured. So if someone needed, say, Windows UBC VPN setup, or they needed the MATLAB setup, they can just click on those, and they're already pre-configured with all the software, and they spin up, and you're good to go with everything you need. So it's really handy for a lot of our students who need Windows for things like MATLAB. Yeah, there's quite a few of them. So yeah, we'll go with Windows. And then this is a bit different. So we just go across the top here. Address, Windows demo today. And it checks again. And these are all publicly available. These get tied to public IPs. So yeah, these are real addresses. So machine type, because it's a Windows machine, I generally go with the largest one. The nice thing is that some of our MATLAB users, this is where that's been really handy, is they've been able to select a workstation with 4 V100s and then run MATLAB on that for their high-end GPU jobs, and it works wonderfully for them. And not many researchers are able to grab that kind of resource on the fly for so cheaply for a few hours. So it's really nice. But we'll go with the T4 large. Storage, I tend to go right away with a root drive. I go to 300 gig just because you never know, it's Windows. And I believe, yeah, it's good to go. I'll click on the button. There's your administrator, the default user. So password. Doesn't probably like this. It might not, yeah, it won't let me launch it. So it's really strong. So I'm gonna have to create something here. Sorry about that. Okay. There we go. Wow. Good. So it's a long one. Launch a machine, and this one goes really quick. And we'll just leave that in the background. And so I'm going to go back to Autoscale clusters. And because I have one up and running, I'm going to show you that right now. Because I don't know, yours is just probably, yeah, it's still in progress. So I'm just going to go to this, and I'm going to go straight over to the one that's already running. So I'm going to use Open with Ronin link. So Ronin has a really cool third-party app that you can install. So you can connect to the machine through the desktop, through the SSH client, every way. So you don't have to worry about third-party software. So that's really nice. So I'm going to go with that. Click on that. Open link. Oh, it's already there. So it says yes. Good. We are. There we are. Okay. Close that. And so it's available. I'm going to connect to the machine, and I'm going to go to the terminal because I want to be able to run a job. So say I can run back quickly here. Object storage. So say I needed storage and I had my project and I needed to set this up and I wanted to upload the data to this whole project space. I would set up a new bucket. It's really simple to do. You just create a new bucket. Sorry about that. Create a new bucket. You enter the name. New day, test day, create storage, and then you attach to it. It uploads a key to you in an Excel form, and you just follow with an AWS CLI install on your head node. You would just connect to that using AWS configure, and you'd be able to connect. It's just a GUI, just a series of questions that you connect to. Then you'd be able to connect to that local on your machine here. So for example, I think you guys could probably see my Linux shell. So I believe I have a history. S3, and you can see this would be the command. So that's one of the attached buckets I have, and you can see that they're, I don't have to be connected to anything. I can see that, so I would upload my data to that, and so there you go. I've got the bucket, and so I go back to the Autoscale cluster, and that's where my data is. So there, and I put it in shared and apps. So now I'm going to go here. I'm going to go to shared or apps. Shared, no, sorry, FDS. And there's, this is where I have all my everything running. And so I used, because I knew it was Slurm, I created my Slurm script. So that's the FDS. You can see that's an average script that would set up, look for the nodes. In this case, it's just going to grab 4 of the 10. And so I would just run this, I would run this, and it would grab everything I need. And then you can see it's running and waiting to go. Let's see what happens, right? So now it's just waiting. So to say everything was working and everything was great, and the job ran, and you wanted to see the results, you go back to the Ronin link here, and I would say I want to connect, and I go to the desktop, and we're at 36, so I'm almost done. And this will give me the Linux desktop or the head node. Okay. So I've already logged in and I booted up, I just have an Xterm and I went to the results. I've copied these because I didn't want them to get overwritten, and because I knew how to run my program, because I'm familiar with the fire simulation. I would run smoke view, and then fire fds.smv, and it would pop up, and I would get the results of my job, and I could see, oh, look, there it is. And same way, we'll just throw some temperature, look at a temperature simulation, and then it would play for you, and then you could look at it in different ways. And yeah, so then I would have my results, and that's after the job ran. So that's, that's the handy thing of being able to spin something up so quickly. And then if you went back to the machines and we went to the machine summary, back to the Windows side is already all set up. Okay, it's running. And so I want to connect the desktop. Again, we can use the Ronin link. Oh, it's asking for the password. Let's see if I can remember it. Oh, look at that. And again, I can connect to the desktop. Oh, it's going to install. Cool. Because I haven't done that before on this machine, so it's installed that. It's going to install, I think Ronin works with Amazon, and they have some clients that they install to make things faster. It's like Amazon, AWS's Windows version of remote desktop. I personally prefer remote desktop Windows version. It's a little bit faster and snappier. But this works just great because it doesn't matter if you're using Mac or Windows. If you have Ronin, it'll install the app for you automatically, and you can connect to it no matter what. So it's kind of handy. I wonder if the job's running yet. No, I think I might have screwed up. I was playing earlier. I actually have a workshop next week, and I think I might have changed the script to 20 nodes when it should have been 4, and I've only have 10 that we scheduled. So I think that might be why it's stuck right now, quite honestly. Sorry, guys, but you get the idea. Okay, there it is. And as soon as this is up and running, I'm going to hand it back over to Jacob, because I think there's 2 more slides for Jacob's end, right, Jacob? Yeah, right. Okay. And there you go. So now you have a Windows desktop, just like that. All right, so I'll go back to the slideshow, and I will stop share for a second and load that back up. Okay, off to you, Jacob.
All right, thank you, Ken. So just kind of to wrap up our presentation, we wanted to give a few viewpoints of 2 of our research groups that had a great experience with Ronin. Our first group is headed by Kevin Layton Brown, and they use Ronin to look at and do a large simulation study of attempting to repurpose radio spectrum as part of expanding the wireless internet bands. And they found great use in Ronin with the ability to use the autoscaling cluster, as well as just having the high flexibility of the type of architecture. So if, say, they started their simulation, they wanted to run a primarily CPU-based part of simulation, they may need a lot of RAM for that portion. So they could build up a cluster quickly that suited the needs of that part of the workflow. And then they move on, they need to do some refinement. And that part of that involves some machine learning. They need some GPU. They can then spin down that CPU system that was set up originally and then switch back over to GPU. And they found quite a bit of use out of that for their sort of research of kind of bursty workloads where you don't want to invest in buying specific hardware or trying to get access to a HPC research system for a large number of jobs in a very short amount of time. And that was where they found probably the greatest use for Ronin. And then next slide, Ken. So our second group was headed by Sharif Osman, and they're doing structural analysis. And part of their work is looking at various different structural materials and trying to run cases of where faults can show up. Their biggest use for Ronin was that during the height of the pandemic, they had quite a bit of restrictions on coming into campus and doing physical experiments in their engineering lab. So they needed to start very quickly switching over to doing much more simulation work. And as a lab that hadn't really done extensive simulation work off campus, they really didn't have kind of the local machines needed for that kind of setup, and needed something with a bit more power than what they could get out of, say, their campus laptops or even a few of their workstations. So Ronin had the ability to basically say, here's some cloud nodes that suit what you need for your simulations, and they can be spun up and spun down on demand for any of your researchers. And this helped them with kind of keeping their graduate students on track for finishing their dissertations by kind of supplementing the work that would be done in the lab on physical material with more simulation work and more heavy computational work than what was originally planned. And this was probably their biggest help, of just having that ability to spin up on-demand workloads that or hardware for workloads that normally would not be feasible under kind of a desktop environment. And with that, we'll go on to the next slide, and I think we'll wrap it up here. And thank you for attending our talk here. We'll go through some of the questions that have built up, and if there's any more questions, please either say them in chat or ask to raise your hand and unmute.
So I've been collecting some of the questions in the call doc. Some of them, I'm not sure who asked them. So like the first one, somebody had asked the question, is this suitable for GovCloud deployment? So I'm not sure if somebody needs to add a little bit more to that, but we'll throw that question out.
Yeah, so regarding GovCloud deployment, so the way Ronin is deployed, maybe I can actually hit two questions at the same time because I saw another one come in. It's actually just deployed as an instance within your AWS account. So it actually is an EC2 instance that's installed. I think it's a T3.medium that sits in. So whether it's GovCloud or any other type of cloud, if you have access to EC2 that sits inside your account and that service is enabled, it should work. So it's not a platform as a service in a sense, even though it is a platform. It's actually just an instance that sits in your AWS account. So I don't see any reason why it should not be able to deploy in any AWS account. The other question, sorry, that Roland asked was, how much did it cost to implement Ronin in time, staff, and hard costs? So I don't think we calculated a bill, but it was just when we first deployed it, it was one of the Ronin engineers and myself. So essentially it's two people that deployed it, and probably, maybe a couple of months of back and forth to get it installed and then get it integrated with our university IAM system. So it wasn't too much in terms of that. Obviously I can't give you a number as to what it costs in terms of staff salary and things like that, but it was a couple of people, myself and one Ronin engineer. And I think within the first month, we had it running. And I don't even think we're working on this full time. It wasn't like 4 weeks we're working on Ronin. I might have worked on it maybe 1 or 2 days a week just to test things out and get it going. So hopefully that gives you a rough idea, because it's a single EC2 instance that sits in your AWS account. Maybe the more complex part would be integrating with your university's SSO and doing group management and things like that. But I think most universities have some form of SSO that uses SAML 2.0, so it's fairly straightforward to do that. So are we using direct?
I understand that Ronin is licensed on a per user license. So like, what were your licensing costs?
Yeah, so it's licensed on a per user license. And I think for a 500 user license, forgot, maybe it might have been 20,000. I'd have to look it up exactly to see, but I think we got the 500 user, and that's for a 3-year period we initially had it for. So our license is up this year. So we figured it was worth that because we were doing it as a part of a POC. But I think they provide, the company doesn't have fixed pricing on that, as far as I know. I think they'll work with you to see what fits in with the number of users you have and so forth. And I think the hope eventually for them is that it's actually something that's offered by the cloud vendors as such. So there is no licensing. I think that's the eventual goal they're trying to move towards, is that it's actually a platform on the major cloud vendors. But I can't speak for them, obviously, but that's kind of the vision that they have, in a sense, that it's provided just as part of a cloud vendor's platform. The other question is, Josh had a question about, did you pair it with Direct Connect? No, so we're not using Direct Connect now. Eventually, we do want to implement it on our university tenant. Our university tenant is using site-to-site VPN still, but we want to get to Direct Connect at some point just for higher bandwidth. But we're getting about 10 gigabit per second on our university tenant with site-to-site VPN. But for this POC and this pilot service that we didn't even do that. We just set it up in a separate AWS account, used public IPs for access, and just restricted it to our VPN service for the source IP. So Direct Connect would be nice if you have really large data sets, because then the egress can get pretty large if you're pulling things out, and that's an AWS thing. But if you're not doing that, just trying to test it out, not strictly necessary, and we haven't done that.
I think Greg has a question.
Yes, thank you. Thank you for the presentation. And I want to start off by saying it looks really great. And if we had this in place on our campus, we'd be using it today for a lot of researchers. So I want to start off with that. But I want to play a little bit of a devil's advocate for some discussion, perhaps. So what I saw presented with Ronin, it kind of felt like a packaging of some of the least common denominator cloud services, VM and storage, and some HPC or batch jobs. And a lot of campuses have those kinds of services on site. And so then when I look at it through that lens, the first difference I see is this is, a move to the cloud, which has a relative infinite scalability compared to campus resources and that hardware investment and so on. And also perhaps a UI that's that looks slick, and I mean that in a complimentary way, in a good way, and is nicely simplified compared to the cloud vendor's UI. But what I'm wondering about is about the opportunity for higher level cloud services. I mean, folks talked about, for example, taking care of some system administration tasks. Well, like if you use, for example, a database service from a cloud vendor, you don't worry about the VM, or a service from the cloud vendor that runs a Jupyter notebook, you don't worry about the VM. And I'm wondering, what the sort of trade-offs are here, or are there missed opportunities by, in a sense, again, I don't mean this to be sort of attacking, but walling off all of the rest of the huge spectrum of cloud services. I'm curious about your thoughts.
Yeah, 100%. I'd actually agree with that assertion. I think in this case, we're providing, those lowest common denominator infrastructure as a service, but we also see things moving more towards the platforms as a service side, right? Like what you said, SageMaker, managed database, Jupyter Notebook, and so forth. So, and even HPC, in a sense, even with Ronin, you have to still have that collection of Slurm submission scripts and be able to submit those. So the idea to have something even to wrap around that sits on top, that you don't even need to do that. We see demand for that as well. And there are things like grid.ai, lightning AI that some faculty use, that in a sense, it's just, you just say how many cores you need, how many GPUs you need, you point it to a GitHub repository, it pulls everything and runs it. We see that as kind of the future. Infrastructure as a service is still required because a lot of people are still doing traditional things. But I 100% agree with you that it's moving towards that, if it hasn't already, those higher level service offerings that you don't even need to worry. And I'd say I'd call it serverless, not in specificity to something like Lambda functions or functions, but something where the researcher doesn't even need to know about the servers or cores or things like that. And you just run the job, have a Python script, and they just run it and say, I need this much computation capacity, and it just runs and it copies the storage directly. So we see things moving there. I would say Ronin is still on the IaaS side, and moving towards that PaaS side is something we're looking, things like Open On Demand, Jupyter Hub, which we have deployed on some systems. It's there. So, and also to stress that with Ronin, totally agree with again, what you said is we're using it right now as a supplementary type of offering, because our primary stuff is still on-prem, because at this point in time, on-prem is still less expensive. It's getting to the point where the CPU price on cloud is actually becoming competitive, but things like storage and GPU are still more expensive in commercial cloud. So it's used where a researcher needs to scale up to things that doesn't work, or in that other case where on-prem is oversubscribed. I have 2 weeks left to submit a paper deadline. I need to run this now to publish my results. And that happens more often than
it happened to me on Tuesday. On Tuesday, I need lots of a VM with multiple GPUs, and the paper's due in 10 days. I get it. Yeah. Off to the cloud.
Yeah. So definitely platforms is there, and having those managed databases, SageMaker, that's another thing that's in quite high demand. Lots of people like that. So it doesn't cover the whole gamut. And I'd still say at this point, it's still that infrastructure as a service with some additional bells and whistles.
Cool. Thank you very much.
No worries. Clifford has a question.
Yes, thank you. And I'm not sure if this was covered. I had to show up a little late, but I realized that Ronin has a way of tagging the resources to make sure that each project is associated with certain groups and whatnot. I'm wondering, from an actual implementation standpoint of getting those bills paid, how has that experience been, like in terms of making sure that those bills get kept track of? And I don't know if this is all existing in shared accounts, so there's got to be someone who's staying on top of that as a billing task. What has that experience been?
Yeah, so the billing administrator, and that's super important. You need somebody to actually look at those grant codes and that billing code and actually reconcile at the end of the month, hey, how much has been used, and somebody in finance deducts it. So I'll say this, right now, since we've launched, we've just been running with our own internal ARC funding and pool of credits from Amazon, and we've been allocating those to researchers. We do give researchers an opportunity, and that just started recently, that, hey, you might get your own pool of credits from Amazon, or you can bring your own grant funds into Ronin and say that, hey, these are the grant funds. Here's a speed chart code that the University Finance Office uses for the billing. We haven't had a researcher come to us yet and say, hey, I want to onboard and bring my own credits, because we've had a fairly generous allocation from our VPRI and from AWS directly, and we've just been handing those out. But I think we're reaching the point where, we might actually have to start charging researchers, and I think the way we would do it is we would have that speed chart code, which is used to bill back against grants. But the whole cycle, I'll really admit, we haven't had a need to do that yet because of the allocation that we've had. But you absolutely need to develop a billing process using some sort of arrangement with your finance office. How do you reconcile and subtract the grant money at the end of the month? And how do you pay that bill to AWS as well, right? And we've been lucky so far that we haven't run out yet of our initial allocation of resources, but I think we would need to develop a process for that.
So the implementation, like the resources that get deployed with Ronin, they're not into, well, correct me if I'm wrong, they're not into individual accounts that are associated per project. It's into a shared set of accounts, and the projects are just kept track of. Is that correct?
Exactly, yeah. So it's a single AWS account. So it's single AWS account, single AWS account number. And what happens when you create a project, it creates a unique cost allocation tag for that project. And each time the researcher deploys resources, those resources are tagged with that cost allocation tag from AWS, and it'll compute the cost that's assigned to that particular project. So all of these projects it uses subnets and some separation. They all run in the same AWS account, but they're subnetting and some group management that keeps them separate. So they can't talk to each other, and all the resources have their own tag. So when you go into AWS billing, if you look at the backend billing, you'll see them all show up as separate resources, and you can do a calculation on each of those to figure out the cost. And that's how Ronin does it as well via the API. So yeah, not separate accounts, it's all a single account. So the actual, if they were actually paying for it out of their own grants, for example, you would need to tell them, hey, this is how much you use. And Ronin does give you that, and you can export an Excel file and see how much has been used of all the projects, and that it can be handled by finance. So yeah, it's a single account, but uses this tagging. And that's an important piece, that tagging has to be enabled in your AWS account in order for Ronin to actually correctly compute the bill per project.
Mm-hmm. Yeah, that's really insightful, because billing is definitely not a trivial task. And I can imagine it, when it comes to researchers getting their own sets of credits, it'll add a new layer of complexity to it.
Yeah, for sure. I would say that they get their own set of credits, or even if it's cash value, just have to make sure that when you create the project, you put in a billing code. Just have to make sure that that billing code is something that's kept track of at your higher level finance office or your administration, that, hey, they know what the billing code is, what it's used for. So at the end of the month, when you see that bill and we see it split up by billing code, that this project used this much, it doesn't come as a shock. And I'd say that's definitely a business process that we haven't had a need to develop until now, but possibly very soon we'll have to start doing that as we draw down on our existing allocation.
Thank you.
So maybe just a quick subtle follow-on question to that. Is there then protection that stops somebody from going beyond the limit of their allocation? So
Yep.
So there's something called auto pause, where projects, sorry, Jacob, I started talking at the same time. Auto pause, so the projects, you can set an upper threshold, like a hard limit. And what happens with auto pause is it'll automatically shut down all the resources in that project and send an email to the user saying, hey, the project has been shut down. What it doesn't do is it doesn't touch the storage. And the assumption is you don't want to delete anyone's research data off the system until you get in touch with them. But the storage is still being billed. But the feeling is storage is still significantly cheaper than running 100 GPU VMs and keeping those running. So it'll also send you warnings at 25, 50, 75% of usage of your entire. So at least you'll get those emails. And finally, you can set that upper limit threshold where it shuts everything down. And then an administrator can go in and contact the researcher. And we've had that happen because sometimes people just forget. There's also a scheduling system that Ken didn't show, where you can schedule VMs and clusters to shut down and start up at particular times. So you're not idling them and just burning up credits or funds while they're not being used.
Great. Well, we are at the top of the hour. We really appreciate all the effort Jacob, Venkat, and Ken you put together into this presentation. We appreciate everybody's participation in today's meeting. Is there any quick last moment questions or things we want to give? If not, thank you again for the time and effort to our speakers.
Thank you so much. It was fun. It was a great turnout.
Yes, thank you for giving us the opportunity to present all this.
All right. Well, with that, I will close out the recording and we'll close out the meeting. Thanks, everybody.